hello everyone. Thank you for joining me today on my presentation. So, let's start my presentation with very simple thought. What is our understanding of the current reality? And the question is, are we advanced or are we at just the beginning of our journey of understanding? The reason why I'm asking is because the clay tablet that is up there, it contains the most accurate sexagesimal approximation of square of root of 2. This tablet has been created 1,700 years BC. So it's roughly 4,000 years old. And the margin error is 0.00042. It's not the matrix. What we are, you haven't taken a blue pill nor the red one. It's real. So you see how all this our understanding is from Babylonian era. Aside the fact that the reason why we use the watches and 60 is coming from Sumerian. So it's way older. So, welcome to my presentation. We will be talking today about Java platform module system and my experience with Robo4j and other open source projects. I hope you enjoy my new perspective of the Java module system. So, here is my favorite slide. I am Miro Wengner. I am in Java ecosystem for a couple of years. So what I wanted to mention here, I authored the book Practical Design Patterns for Java Developers. And the reason why I'm mentioning is the word patterns. You will see that the patterns will be emerging on my presentation, basically everywhere. And maybe you will be able to adjust those patterns on the project you are working on or the vision you would love to create or kind of implement. I work for a very nice, awesome company, Open Value. So the point is here, we are doing, at the end of the day, we are doing a job, right? But the main motto of our company is to having a fun of during the work, right? So we are in the Euro, but we are the group of people, are sharing the main goal, and to be better in technology, to be better in understanding of JVM, and we went far these days behind the JVM. So we offer the trainings, also consultancy, development, migration, and way more. Here is the short agenda. And this brings me here. So what is the evolution? Yes, the evolution is a transformation. We see it in our daily life. It really depends. Yes, sometimes we fail forward, sometimes we fail backwards. But it still evolves the content basically every second, the context we are working on. And the context is very nicely defined. So maybe you all are aware how big hype we have today with a kind of AI agent. Okay, it's very nice to have a ChatGPT and everything. I became a millionaire yesterday. Oh no, trillionaire. Just using the ChatGPT, he told me then afterwards. So what my point is here, that it may hallucinate. I'm still not trillionaire nor billionaire, not whatever. So, but it may hallucinate. And the hallucination state of these agents is very easy to achieve. So, but, I mean, the major technology shift which we are witnessing today is very silent, it's running behind the scene, and it's a quantum computing. What does it mean actually with the quantum computing, just for the beginners and just understanding, you may explore at the, let's say, time zero, all the possibilities you ever can have simultaneously. That means in the way of parallelism we are not able to think about and to absorb today. And these big players like Google, IBM, CERN, which is not a player, but I mean Microsoft, Majorana chip. So you may already heard some information about the achievement, and also you may heard that some of the research points they've been just stopped. There could be the several reasons aside of kind of physical possibilities we do have right now today, but it could be also that it may deliver the result where we are not able to understand, we are not able to interpret. So our current knowledge of the physics and math is maybe not enough. And as we playing with the quantums, with the qubits, on very deep level we are playing with the matter, yeah, on the level behind probably the atoms. So the people may not be sure what's going to happen because there is missing a framework that could give us the signal. As you may see, that I put the slides here, the market of the quantum computing is really getting up in the percentage, right? Currently, these experiments are very expensive, so you can imagine if you multiply with 2,000 times, and it's kind of near future, year 2007, so 27 actually. So it is going up. So and the same, all these and the quantum computing is extremely important. One thing aside of patterns, to have isolated context. And as we can see, the JVM, the JDK, is already on the track. There are two JABs trying to address the issue with the context encapsulation, and then the cryptography, kind of communication between those parts, because you need to anytime ensure that the messages you have received are fine. So that means actually, and the other way, on the bottom line, that the complexity of the kind of reality we are experiencing is increasing. And it's not going to be better. So, but what we can do about that? That's the good question. We can hypothesize, we can have an idea, and we can formulate a vision how we'd handle this. But we can go even farther. We can encapsulate and very strongly our idea. And we will today talk about how to develop our software to follow this idea of strong encapsulation, where it could be easier probably in the future to kind of adjust to the quantum computing, where this will be the requirements. Because you cannot run kind of undeterministic software, because then you don't know what you have. And as you can see, here is the output of the modules from the different projects I'm using today, and the hand is running here, automatically moving. And this is from Robo4j, Pi4j, there is, you see, SLF4j, and all these modules, as you see, they are, all these artifacts, they are already modularized. That means they're using the module path. They can run, you can use the J-link, you can extract, you can create a nice and very teeny JVM. So, but before we go there and even start to think that kind of complexity, I grew up as a child at the countryside. As a small kid, I was very excited to see these heavy machines. You know, every year the cycle is very same. Yeah. And reaping the harvest at the end. And I didn't understand like fully about what is happening, but what I did understand already as a small kid, that everything needs to grow from the ground. So it's not falling down the sky, right, these products. It leads to me later at the university, I heard the Tim story just taking a note about the theory of harvesting, and which is very simple theory. I mean, he put it on the diagram. So in order to reap the harvest, the first at the beginning, you need to plow the ground just many times as you want, as you feel good. Then you plant the right seed. Then you need to water the seed in order to grow up, and then you reap the harvest. Just very simple. At the end, you have a product. And if you are not satisfied and happy with the product you have, you just do it again, right? And do it again, and do it again. Just repeat. And you just try the different approaches until you have the product you really want to have. So the product, it could be anything these days. Actually, it could be some kind of article, substances, whatever you can sell. Or it could be even the person. It could be actually, it could be the product, because the athletes are actually the product of the continual work. Just repeatedly work, following the repeatable same patterns to get better. So it could be food. So, and in the context of the IT, what is the product? It's the information technology. Yeah, it is. So we as a developer, we are responsible, we think we are responsible just doing the software, just delivering the artifact. Yeah, but that is not end the story for us. The artifact we do use is actually using the hardware, some kind of platform we decide, like a target platform we decide to use. And we need to be also nice to the platform. And what we don't see is that this kind of platform, in order to be able to run, it needs some resources, right? So where resources are coming from? From the planet Earth, right? And planet Earth, it's like an electric bubble that is kind of providing all these magic resources where we can run our software. So the software, our responsibility is to write a nice software, just deterministic one, that use the hardware properly, that it can use this. It is the hardware itself is able to use the resources properly. So, and this means me here. So if I would love to run the software, or you already didn't have to have a vision because you're already working on a project, but you can have a vision how you do your work or how you kind of create a new one, the modules. So in that way, I had one day, like I'm getting old, so like probably 15 years ago. It's just it was not the same idea, like, but it was very similar to James Gossip, just control the hardware, just using a Java. Yeah, just pure Java. That is the Robo4j is coming from. It controls the hardware. It controls all the time. So, but before even I get there, I need to put it on the table. So we spent the nights together with a friend of mine, and we've been really like brainstorming what we gonna do with this, how we gonna do this all. And what came up is this chart. So we already separated, isolated, encapsulated our ideas into the modules that we will use for the development. And we haven't written much code before. Okay, we wrote a code like to try the hardware itself, whether it works or not, but we have not started yet. So it was still on the paper, basically how we can do this, how we can approach it. So that means the point is here, so it's very great to start from the ground, like the plotted ground. So, and taking the right seeds. So we took the right seed, which was the white paper and pen, or whiteboard, which was the electrical one. And we draw this diagram, and you see the separation, the core, we identify, we HTTP math, and all these things. And we also draw the direction, how it's going to be used. And then it was not enough in the hardware, because what we've been expecting is that we need to execute those tasks. Let me do this very small break. I'm very sorry, I need to just shut down this guy. Just slowly. You get a real experience with the Robo4j. Just plug it out. Yeah, I don't want to fail it down. It has been working. But I lost the controller at home. Oh, I didn't want to happen. Okay. So, let's run it again. And here we go. Cool. So, we can run it again. Perfect. And continue. So, we have this nice diagram, just to repeat here. And we wanted to do the work, actual work. So we would need to threading model because we would love to execute the situation at the parallel at the same time. And we had a lot of sensors, like a temperature one, detectors of the humidity. We have also just detection of the position of the in this case robotic arm. So we could detect all these. So we collected a lot of information at the same time in a parallel. So we had to create the threading model. Yeah. And here we say, okay, we're gonna have some worker, right? And what we need is some kind of task that need to be created repeatedly. So we isolated, okay, it's a scheduler. And some of the tasks, some of the servos, they will provide just the continual byte stream of the data. Yeah? So that in this case, everything needs to be blocked in order to not compromise the rest of the running application and run very smoothly. So we had this, and just powered of this, we started our work. We have already these modules. We know how it would look like. In that time when we started, there was no Java platform module system available. But we already have it in the mind. There will be at some moment in the future that this feature of Java will be available, or this functionality of Java is not a feature. So we started to programming, executing our ideas, and we failed. We born some sensors, of course. We evaluate our state and we repeat. And you see the very pattern is very simple. It's like a harvest theory I mentioned before. But in each step, even when you're doing the test and applying your ideas, the patterns start to emerge. It's like a unit testing, right, this chart. You just prepare, execute, and evaluate. It seems like another pattern we made in a clean code, right? So in the software development these days, so we trying to apply some frameworks, but they are having, although it doesn't look like they have indirectional relation to even the Java platform module system, yeah. So we know what is IPI, the pillars of OOP, right? So we know how to abstract, we know what is polymorphism, we know how to apply the interfaces and encapsulation. You see the word encapsulation is again here. We do it solid, we try to follow the clean code, and then we have a Scrum, right? And this is the diagram there, but if you take a look on it, on the diagram, you see the product goal, as actually they call it backlog or product backlog. Okay, and I may think that this is not at the beginning. You can have a vision, but as you're doing through the execution of the sprint, where you define the sprint goal, the context is dynamically changing with each implementation you have. So that means that, again, all of your ideas, it's kind of very nice when you are encapsulated enough that they are ready for this dynamic change of the context, that you actually keep the flow of your product, of your software development. And here, that is a very simple chart, again, just inspired by theory of hardwares, how you may think about what allows you, what supports actually you to use the functionality of the Java platform, which is the Java platform module system, and how to use it. What kind of requirements your software should follow to be able to do this? Actually, not with keeping in mind the dependency inversion. It's very nice. It's a very good start to keeping. Actually, you should not provide any implementation dependence on the higher abstractions on it. Otherwise, you end up in mess, and you would need to kind of end up in class path indirectly. So patterns start to emerge if you apply this routine, actually this cycle, and you can follow the dynamic context. The software, actually, how I see it, is actually artifact itself, but platform belongs to it. The single artifact has inside the information where it's going to be run. Although the Java provides nice description of current module system, you see how simple it is. This is extracted the chart from the latest Java, right? Because we already removed some of the packages. They are not available anywhere. And I just saw on the internet there is a still old image from the project Jigsaw, right? And it contains like a Corba and so on. That's not there anymore. So this is the simple version one. But the point here is a pattern, is one-directional dependencies. As I saw you before our brainstorming giant in Robo4j, it goes kind of nice, and it's very transparent. And what is more, it's transparent to the platform. The Java platform module system, what I saw, what my feeling was, it has tried to deliver as a feature, but the same like the streams and so on. In my understanding, it is not the Java feature. It's kind of way how we should deal with the platform. It's kind of descriptive way how we should use the platform itself. The reason for that because Java is actually using the JET compiler. What it does, it reads the line by line, the bytecode, and translates it into the machine code, right? So it depends on where your implementation is running, So you see, it's not like a write once, run everywhere. It depends on the implementation for the platform where you can execute your jar file. And the point is still here that even then, at the runtime, each time your bytecode is compiled to the machine code. So you need to be really kind to the platform when you are running. And currently, very long time, we had the class path. It's a nice, cool stuff. You just put everything there. Today morning, I have been eating my breakfast, and it came up to us a really nice idea, just how you can imagine the class path. Oh, it's like a shop where you have everything for free, even the sales guy. You just go there. There is everything for free. It's good. You can take it and you can execute it. You can put it in the back, whatever. Just it's for free. It's a class path, right? But it's vulnerable to all different kind of not only security issues, but issues with your artifact. It's not definitely deterministic. What is happening? How are you dealing with the platform you are running on? And that's the problem. As you heard, this quantum computing, right? It's strongly dependent on the context isolation, on encapsulation, because the information cannot go outside of context we are working, where your calculation is. The quantum computing can explore simultaneously multiple realms at the same time, and then it collapses into one result by the observer effect. So there is nothing like a context interference. All runs in the isolation itself. So the class path is very hard because still it's like open shops. It's like the all realities collapse together so you can have everything. That's very cool. So compared to that, the module path provides a very nice descriptive way how you can be nice to your platform where you are running. How you can ensure that behavior of the artifact is deterministic enough that you can formulate your ideas and verify the hypothesis about your product, how it should behave. Because we have tools and we are using daily tools to ensure that it behaves like this. Basically, the pattern that emerged here, the producer-consumer, everyone used the Kafka messaging system, and whatever these kind of real-time technologies, right? Maybe these days. But the pattern is very simple. It's very same. Someone produces something and someone receives, consumes something. And this is same here. And the idea is used to create these descriptors. Yeah, so you can be unsure. And what is the more nice? Maybe you missed a line here. If you use the module path, you get the security at the compile time and runtime. That actually the compile time means that if you have your architecture wrong or you have the challenge with pop-ups, which is happening all the time, you can address it. Yeah, and it's very transparent. You can put it into your Scrum, into a running sprint. You can address the issue. And what is more, it's visible. Yeah, so you are not hacking behind the scene in the class path, actually silently going into the shop where is everything for free. Yeah, so you are not doing this. You are doing this transparenting, and the whole team is aware of it. And the module path actually may be the description, this documentation of the architecture of your product, which is awesome. So, and here is an example how it looks when you forget something. Yeah. So you see, you have here the illegal access exception, right? So what is happening here? I didn't expose the model, probably the monitoring unit to the Robo4j cores. So you already see here one directional relations, and the compiler tells me he gives me the hint. Okay, man, you have forgotten this thing. So you feel the security that you are becoming where you are putting your project on the module path. Yeah, and this is the fix. Okay, cool. It's very nice and easy to do. So the module path provides you some descriptors, some of the keywords you can use. You can actually decide on your own what you're going to export. You can also use the same packaging naming. You don't have to avoid it. Just think it's not landing on the module path. It will be isolated. Yeah, and you can expose in the way of the pattern producer consumer. You can expose the services, and you can also provide a different kind of implementation. What does it mean is you can have the modules that contains the all abstractions that are required, and you can each time use for the different module different kind of implementation of that similar services. Depends on the platform. Yeah, you're gonna run, because the driver on the bottom could be very different, like for the connector for the databases. Yeah, on a special one just to customize. So you can exchange them very transparently. In the Robo4j, we use some kind of lookup service exactly for these purposes. We have multiple of them implemented. What it does actually, you run the Robo4j at the network, and it detects all the units automatically at this network. It collects them and it initiates the communication between them. But the result of this is that actually you are communicating between the units, you are receiving the messages, and it behaves, the entire system, it behaves like a one. Although it's running, for example, 10 Raspberry Pis or 10 computers at the same time. The feeling is like a one, like a unit. Each context is encapsulated, deterministic. We know what is happening, and we can monitor it. Just think about it. It's very easy to create the module descriptor, and it's very nice, declarative way, and very easy. And the value you get in the documentation, it's way more, and you can address any challenge. And it's not happening from one date onto the other, so you need to have vision how to do this, some idea, and you need to really eliminate just one step at a time, not just big shots. Like a Rocky does it in my age, just a favorite movie, you know. One step at a time, one punch at a time, and one round at a time. That's like a theory of harvest, right? It's still same. Just prepare, execute, evaluate, repeat. Just do the same. So you don't have to create or modularize all your artifacts at the same time. Just select one, the easiest one, and do this. One punch at a time. Yeah, one round at a time, and then repeat, and you will prevail. at the end, and patterns start to emerge. So this is actually how your beautiful module class path looks like. You see that just beautiful dependencies between themselves. And sometimes what is very nice, you have no idea that it's like this because you are using multiple libraries. Yeah. What is pop up is just when you're deploying the var or artifact in the production, especially in Kubernetes environment, when you need to put everything together, right? It needs to work on, it needs to be deployed on different systems. So just exceptions starting to popping up. And maybe if you are on some mathematical-based software, yeah, that very makes some intensive calculation, you may be not even aware that one kind of mapper has been not deployed, or the old version one, because ClassPath does not care which kind of version you have. If you find a package, right, that is available, if it kind of find a similar class there, so okay, don't care, initiate it. It's in a heap, so it may contain, may not contain the method, right, with the same signature, but then you end up with nice exception. But you actually, this is very undeterministic what you have running right now. Even when you're trying, oh, my code is tested, I have a coverage of unit tests like 110%, yeah, over the normal, I'm saying, yeah, because 110% is not possible. Just over the cliff, yeah? Just the normal. You are very good, so your manager is extremely happy, but you are still on the module path, yeah? Yeah, so you have this shop for free here. So it's very not nice. So what is a way to do? So we can go automatic modules, right? So we don't have to wait until everyone, our team modularizes this stuff. We can start from now. The time is now, right? Very small. And everything what we put into the class path, it goes to this shop for free anyway. Yes, unnamed modules. Even doesn't matter if it is modularized or not. It goes there. Okay, they can be here, but my shop is already right now that one where you need to pay. Okay, so you go the module path. So you have got some explicit ones, yeah, that's the one that you have modularized. If you don't have the modularized, you put into the module path and you put it into the Spring modules, they become automatic. So actually they get the name of your artifact and also the version and so on, but they are already modularized. What does it mean? The context is very separated. It's strongly encapsulated. So it's good, you need to pay for it. So that means that our Robo4j, in the context of our Robo4j, it's getting like this. We follow it, and we end up with demo. And we created this one, and you see this is the first example I have. And you see there are the units, the blue ones, it's the Robo4j. We are using the Pi4j. We actually modularized the Pi4j too. It's actually helping us to, it provides the lower abstraction for Robo4j, how to communicate with Raspberry Pi hardware, how to read the buffers and so on. The Robo4j provides the higher level abstraction, how to work with the messagings they are running from these sensors or for these units you created. So, and this is very nice one. This is, you see, I have it on my example. On my example, actually, I'm using the automatic modules, and if I can show it very briefly, and I can access this guy. Yeah, let's see. This is the metrics. Yeah, he's alive. This is very cool. This is here we have the modules. I will refresh. So he is giving me the information about which kind of modules I do have here, and some of those are automatic. SLF4j is, for example, already modularized here. Yeah, so you can start one punch at a time, one step at a time, and repeat. So, the next one, what I can show you is here. The Grafana is a very favorite monitoring stuff. So you can see, and you can see here, you can monitor each the modules here, and you put into your matrices. So you can monitor, in my case, each unit that is running some kind of hardware or operating on the sensor stuff. And you could put it into the numbers. that could be evaluated, right, and used. So you have you don't get only be sure that your actually application works and it can be monitored, but it works transparently because you are using the platform deterministically. So that means that these numbers that you are getting here make more sense. They have the additional values because you have ensured that you are acting nicely and predictably to the platform. So that's the first one. The first demo is here. What it does here is simply write the buffer, byte buffer, the characters, and display on the LCD panel. There are 3 units, and that's the disk guy. We can see it. You see, it really does not check doing much more garbage collection because the memory, actually the letters are still same. So you can use even the JVM epsilon garbage corrector, which does not garbage collection. So in order to make it slower and way faster. So Java can be extremely fast. Well, even based on some other measurement I did, faster than C. So this is not true anymore for a very long time that the C requires to be faster. No. So the second job we have, this is the monitoring system. Actually, you see, this is actually the demo with the LCD panel. Excuse me for the mistake. So, and the last demo, the next demo I have is the one, this one, where the modules are used also. It's a way more units here. As you see, I have a way more bigger thread worker. I have 10 worker threads, so 3 pool size and scheduler that are running here because each server has some kind of detection in order to not crash. I have more sensors here running at the same time. I forgot my controller at home, so but it's fine. I just been able to very fastly create just the simulation, which you are running right now, which is using 3 servos. It's run in cycle, right? But the goal was just to provide the nice graphical experience here. And what I wanted to show by each of graphs, you see I'm running the Belsoft JDK, OpenJDK, and here I'm running the Belsoft still. I thought that I will run the Azul one. Okay, maybe it's on the 20. Yeah, Azul is on the 20. So here is running Azul. So on the gripper, and on the other, which is here, is that one. Oh, I know. Here is running Oracle one. So all sponsors of our conference are here. So thank you for them by showing in Grafana. So, but you see here what the modules are doing. So actually, right now I have a way better feeling, by using the Java module system because I know where I have encapsulated my contexts. There is always more than one context. Just your context is application. That's great. Your application artifact. But inside, there are way more contexts. Yeah, it goes deeper. Yeah, and it goes also higher because the other context is how your application deals with the platform. And there we have the Java platform module system that helps us to kind of describe it in transparent way, how we do this. And it allows us, it kind of push us to move our vision, our product forward transparently without experiencing some difficulties. And believe me, I had really hard time with the Kubernetes and deploying those artifacts, although it should be automatic something. That's great. But Kafka, Cassandra, and all these technologies that are connected, and we are running like 10, 20, 90, 100 modules there. If you need to put them work together, be dependent on similar a version of library or some different version of libraries, it becomes very challenging, this. And platform module system is playing very nice role here, how to make your life easier. Please don't go where it's something for free like the class path. it's not always great. It can hurt pretty badly. So, this is the conclusion here. Java platform module system is not the feature of the Java like a stream or collections or so on. Yeah, it's not the program, it's the way how we can understand our platform we are operating on, how we should structure it. It helps us to evolve. It helps us to encapsulate our area. It kind of helps us even to follow the Scrum rules in the team or whatever rules you're following in your teams. So, because the evolution is transformation, and transformation is only possible when you have some good ground, because everything is growing out from the ground, like the plants. They are not falling from the sky, and there are no shops for free. Yeah, sadly. And the complexity is increasing rapidly. It's not the ChatGPT or whatever AI agents, they will be responsible for the next technology shift, which is silently running behind the scene. It's the quantum computing, most probably, in my opinion, that would be responsible for that. And is required to have isolated contexts, just not crossing the borders of your responsibilities, of the program responsibilities. And there is a very simple thought here and the pattern to follow, which is the producer and consumer. And even when this is the high-level pattern, there could be apply multiple different patterns. They could be creational, behavior, structural. They could be there, they are all there. Even when high-level pattern, like in Java Platform Module System, is a producer-consumer based. And Java is very fast, also for robotics. And if you would love to deterministic behavior, which that you use the not garbage collection, garbage collector. Or, yeah, you see the possibilities here. But on the way to using it, I mean, if you start using Java Platform Module System, I think platforms start to emerge automatically out of the box. And I think it will be for you way more fun. And I know that during these 3 days I'm at a conference, I have experienced the talk, I try to ask, and many of you, I get the answer, no, we don't use the Java Platform. I knew about it, it's a nice feature. No, it's not the feature of the JDK. It's not the language feature. So it's a functionality, how your descriptively should work with your Java platform. So we don't use it, okay, but maybe my new perspective can give you the guidance right now to start, because it makes sense, it makes your life easier, it makes the project easier. So it means at the end, it's like you take a blue pill, right? Like a matrix, at the end you have a happiness. I mean, good feeling from the job. Thank you very much for being here, for listening to me. I hope I changed your view on the Java, or skepticism on Java Platform Module System. Just showing the robots, they're running kind of deterministically, that it may work in production also. So I hope you start thinking about that. And remember, you can really start small. It's not the big bang, right? So you can start small, and the patterns is very simple. Thank you very much. And if you have any questions, come to me. You can feel free to ask. And here are some references. And that's all. Thank you very much.